Hi all, I'm Giovanni Bekis, I'm member of Apache HTTP DPNC, and today I'm gonna talk about ACME protocol and modmd. Modmd is an Apache HTTPD module that has been created to ease all TLS related operations from TLS management using ACME protocol, so automatic HTTPS certificate management and HTTPS certificate renewals, OCSP stapling, and all what's related to TLS in Apache HTTPD world. A bit of history. SSL is old protocol. It was released in 1995. It has been deprecated later in 2015 in favor of TLS. TLS is much more secure. SSL is actually absolutely deprecated and won't be used. HTTPS is the short form of Hypertext Transfer Protocol Secure. It can be called HTTPS over TLS or HTTP over SSL if SSL or TLS is used as the crypto layer. modmd works on both on HTTP over TLS and HTTP over SSL. Obviously, all the SSL should not be used because it's not secure, and the same for all TLS versions. At least TLS 1.2 or 1.3 should be used in real world secure websites. HTTPS certificates are of basically three types. Domain validated certificates, which is the only type of HTTPS certificate that can be automated using ACME protocol and CA that supports ACME protocol, like for example Encrypt. This is because domain validated certificates check only if you can manage the domain. It doesn't check if the domain you registered is bound to your company. This is something that it's a manual operation that is done when you require an organization validated certificate or an extended validated certificate. So due to this manual operation and manual checks, only domain validated certificates can be deployed using ACME protocol. What you should do to have an HTTPS certificates without any automation, so the old way is you have to choose a certificate authority, you have to select the certificate you need. At this stage, if you need an OV or EV, so organization validated or extended organization validated certificate, you have to do the old way, so a manual approach. Otherwise, you can use ACME protocol and automate all the stuff. If you want to proceed the manual way, you have to purchase the certificate, you have to generate on your server a certificate signer request and send to the CA. Then when the CA has done all the needed checks, you have to download the SSL certificate from the CA website and install it. Then you have to remember to renew the certificate in time. ACME protocol automates all of this. Is communication protocol that permits automating interaction between CA, so certificate authorities, and web servers. So the web server just asks the CA that he wants a new certificate for his domain. It generates CSR. The CA signs the CSR. After checking that the domain is valid, and in completely automated manner, it installs certificates without any manual user intervention. Basically, the protocol is a key exchange between the web server and the CA. So the web server asks the CA you want to sign a certificate. The CA tell the web server that to prove that domain is owned by the web server itself. So it tell, well, put this string into this directory and I will grab it, and if the CA can grab the correct file, the correct directory, or in the case of a wildcard certificate, it can check that there exists a particular TXT DNS record, then it will sign the CSR request, and the chain will be closed, and the web server will have its HTTPS certificate. The mostly used ACME protocol available certificates CA is Encrypt, which is a non-profit authority run by Internet Security Research Group, which is a non-profit group created by Mozilla, Google, and a lot of other companies, a lot of other big companies, and the intention is to use ACME protocol to deploy as much certificates for free to have quite all websites protected by HTTPS certificates. At the moment, Encrypt is used by more than 200 million websites, and it's counting, and it's increasing the number every day. There are a lot of ACME clients implementation that has been written in different languages that have different features. I think the most important ones are Setbot, which has been developed by Let's Encrypt itself, which is the default client. ACME.sh, which is completely bash client that uses curl to get an external software to maintain the certificate chain. OpenBSD has its own BSD licensed ACME client. WinACME is a Windows software that made it possible to use Let's Encrypt certificates on Windows servers, and Apache HTTPD modemd, which is being integrated into Apache HTTPD and make it very, very easy to use HTTPS certificates when using Apache HTTPD web server. modemd has a lot of interesting features, some obvious, some not. First one is certificate request using ACME protocol, automatic certificate renewal, so you do not have to remember to run or schedule software using crontab to renew the certificates, because it's the web server that will take care of it. It can manage wildcard certificate support. It has an interface to have certificate status monitoring, so you can, in a very easy, interesting way, you can know when a certificate will expire and if it's in some kind of error states and so on. In a very easy way, you can deploy notifications when the certificate is going to expire or when there's something wrong that's going on, and it finally has OCSP stabling support, so it can use its own OCSP stabling implementation instead of using the standard Model SSL one. Mobile DMD is configuration is based on typical virtual host configuration that you can find in httpd.conf file. You decide which server names are protected, are managed by modemd with the domain directive. Then one important thing is that you have to use any certificate agreement accepted, because when you use Let's Encrypt CA, you basically accept the agreement with the CA, so you have to specify that you accepted this agreement and you read all this legal information that's has been written on the Let's Encrypt website. You define the virtual host as you always do. You define that you use SSL, so with the SSL engine on, but you do not define where will be the private and public keys of the HTTPS certificate, because it's modemd that will manage that and will instruct the core and the modem SSL where those files will be. modemd has a dedicated directory where it stores information. It has some files inside directories. The most important ones are accounts. So you can, for example, have multiple Let's Encrypt accounts for multiple domains or multiple customers or whatever. You have a temporary directory. Basically, files are created in a temporary directory, then they're moved into staging. When the domain is the certificate is finally created from staging, it goes to domains, and then when the domain is renewed, the old certificate will go to archive directory. This is very important because active certificate, private and public keys, both will go to domains directory. This is interesting because you can use, for example, the certificate contained in the domains directory for different uses. Like you can, for example, use modemd to renew certificates, manage TLS certificate, but then not using for HTTP service, but instead you can use for example, email services, using by making email MTA software points to the domains directory. modemd can manage wildcard certificates as well. This is a bit different because to deploy a wildcard certificate, ACME protocol will not ask you to create a file inside the directory as in the standard certificate, but it will ask you to create a TXT record in the DNS. So you have to complete some step in a different way. You have to specify MD challenge DNS so one and a file, and this file, which is used to be an ACME setup DNS in this example, will take as input the TXT DNS record that you should create, and in some way you should write something that automates the deploy, so creates, for example, the TXT record that the CA asked you for, and remove all other certificates. So you need a bit of interaction between HTTPD and your DNS server. You probably need some API that can be provided, for example, by your DNS provider to interact and create on the fly TXT records needed for this operation to succeed. Some more features that can be interesting and that other ACME implementation doesn't have. One important is MD required HTTPS, which could be off temporary or permanent. That means that, for example, you can define that a website must be accessed using HTTPS, and by setting MD required HTTPS permanent, there will be an automatic redirect from HTTP to HTTPS without the need to specify mod rewrite rules. Then you have two different values from MD renew window and MD warn window. So when the certificates will be renewed, 33% will mean that in the 90 days after 60 days it will be renewed, and the war window will be that if it's not renewed until 9 days to the end, it will start modernity will start warning you that something is gonna go bad. With MD private keys, you can define how private key will be created, so you can specify the protocol, the crypto algorithm, and how big the crypto key will be created. So RSA 2048 is standard, but you can increase the key size or change the algorithm. And the content email is the mail where Let's Encrypt will warn you about certificates not being renewed, but ModemD can warn you as well. Certificates that are revocated by external parties, for example, when a CA has to revocate some of the certificates and so on. So it's very important that this email exists and that someone can read this email. Then there is MD stapling and MD stable address, which is an important feature of ModemD, which is a new implementation of MD stapling. So an implementation of CSP stapling. So if you activate this feature, CSP stapling will not be managed by ModCell, but will be managed by ModemD. OCSP responder is a server that the browser asks information to know if a particular certificate has been renewed, has been removed, or something happened to this certificate. With MD stapling off, the browser asks both the web server and the speed responder. So yeah, it first asks to the web server which is the certificate, then asks to the OSP or CSP responder if the certificate is still valid or it has been revoked, and then it finally connects to the web server. And this tabling is a caching mechanism that made possible to improve speed on the HTTPS requests, because the browser just asks the web server about its certificate and about the status of the certificate itself. The web server every Sunday asks the OSP or CSP responder the status and the information about revoking about his certificates, and it creates a cache. So it's on its side it's faster to respond to HTTPS requests. On the other side, it can reply with stale data. Monitoring is done using mod status. So you have information in the classical mod status web page, and other than that, you can ask using curl or whatever web client you want for information, like information on a particular certificate. You can ask for information and a JSON reply will be sent back. This is easy to understand just by looking to it, or to implement some more complex monitoring tools. You have also other informations using different API endpoints. For example, what's the status of the certificate renewal if, for example, it's stuck at a particular stage in certificate process, so you can better understand, for example, why a particular certificate fails in renewing. About monitoring, there is also a couple more configuration commands that's very interesting, which is MD notify CND and latest versions and the message CND. Those commands are very similar and are scripts that you must write that accept an action and a domain name as parameter. So you have, for example, in MD message CND that covers all features of MD notify CND and more. You could, for example, write a simple script that mails you when does any action on a particular on any domain. So you will, for example, receive an email that a particular domain has been renewed, has been OCSV renewed, or is going to expire, or there's an error, and so on. Or, well, you can write whatever you want at this stage. So ModMD is a I think it's very useful tool to implement HTTPS, to ease transition to HTTPS only websites that can be easily integrated in more complex situations. Thank you for listening, and goodbye.